You're going to like the objective to this lesson. It is much better than what we did in section 4.3 because in this lesson you're going to be applying something called the side-side-side congruence postulate and the side-angle-side congruence postulate to prove that triangles are congruent and also to solve problems involving triangles. So before, when we wanted to prove that two triangles are congruent, we had to say something about every single corresponding side and every single corresponding angle in those triangles. But in this new mode, we're not going to be saying something about every single one because of something called triangle rigidity. I was in class, I believe it was in third hour the other day, and one of the students challenged me. They said, do we really have to do every single angle on every single side? If I know that all the sides are congruent, then the angles have to be congruent. And they said, can you draw two triangles that have all three sides congruent and their angles are different? And my answer to them was no, I can't. And that's because of this thing called triangle rigidity that says the property of triangle rigidity gives you a shortcut for proving two triangles are congruent. It states that if the side lengths of a triangle are given, the triangles have only one shape. So out of that we get the side-side-side congruence postulate, which says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. And again, it's a postulate, so we can't prove it, but we know that it is true. It's accepted true without proof. If these two sides are 4 and these two sides are 7 and those two sides are 6, that's the only shape that we can create. We cannot create two different triangles. So therefore triangle ABC must be congruent to triangle, and they named these sides wrong, ABC. If I go from A to B, that's the side 4, and then to C, which is the side 6, this should say, oops, let's get a pen here to work with. This should say triangle from A to B. So I would go from, it looks like an H to D, and then to E. That would be the same as A, B to C. Because HD is congruent to AB, DE is congruent to BC, and AC is congruent to HE. So that would be our congruent statement. Okay, so we can explain why these two triangles are congruent without doing every single side and every single angle. What we can do is we can first say we're given that PQ is congruent to PS. That's one thing that we have. So PQ and PS are congruent. The other thing that we're given is that segment QR is congruent to segment SR. We're given that here, QR and SR. Now the only thing we need is that last side, which is this guy here. Because both triangles share that side, we can say that PR is congruent to itself. And our reasoning for that would be the reflexive property. It's shared in both of the triangles, the reflexive property of congruence. So then we could say by the side-side-side congruence postulate, triangle PQR is congruent to triangle PSR. So that's our justification. This is like a mini proof. Okay, we could write it all up and given and proof statements and reasons, but this is a good explanation as well. It's like an informal proof. Okay, another congruence postulate that we have is the side-angle-side congruence postulate, which says if you have two sides and an included angle, the angle that are between those sides, and they are congruent, then the entire triangle is congruent. So we have our included angle A, it's between sides BA and AC, and A and E are congruent, and E is between sides EH and ED here. See, again, they have the wrong letters here, so let's make sure we write that correctly. We can say that triangle ABC is congruent to triangle. Well, because we listed A first, we have to list E first. And then we went from A to B, so we have to go from E to H, and then to C, and then to D. So EHD, that would be the correct statement there. Again, it's two sides and the angle included between them. So just so you know, an included angle is the angle formed by the two adjacent sides of a polygon. So angle B is included between sides AB here and BC here. So you want to pay attention to what the included angle is. Okay, so here we should be able to use this diagram to show that these two triangles are congruent. So I don't have any way of saying that XY is the same as WV, but I do have a way of saying that this angle is the same as this angle, so I'm thinking I'm going to be using side angle side. So first, we're given that XV is not XV, not the whole thing, XZ is congruent to ZV. And then the next thing that we're given is that WZ is congruent to ZY. So we've got two congruent sides. And then we can say that angle YZX is congruent to angle WZV by the vertical angles theorem. So because they're congruent, now we can say that triangle XYZ is congruent to triangle VWZ by side angle side congruence postulate. So it's a much shorter way of showing that two triangles are congruent. So here it says it showed that the triangles are congruent for the given value of the variable. So they're telling us that the two triangles are congruent and x is equal to 5. So triangle MNO is 7, 5, and 6. So if I plug 5 in here, I get 5 plus 2, which is 7. If I plug 5 in here, I get 3 times 5 minus 9, which is 15, minus 9, which is 6. And if I plug 5 in here, I get 5. So because these sides are 5, 6, and 7, and these sides are 5, 6, and 7, the triangles are congruent now by the side, side, side congruence postulate, because all pairs of sides are congruent. No need to worry about the angles. So just as we can do proofs to show that triangles are congruent the long way, we can also do proofs to show that triangles are congruent the short way. So now at minimum, I need 3 congruent sides, or I need 2 sides and the included angle. So we've got our statements and our reasons, and we'll see what we're going to use, if we're going to use side, 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 or side angle side. So the very first thing that I'm being told is that BC is parallel to AD, and that's given. Now with that information, automatically I'm thinking I'm using side angle side because parallel lines give me some congruent angles. And with that, I can see that this angle right here is going to be congruent to this one. So step 2, angle ADB is congruent to angle CBD by the alternate interior angles theorem, because they gave me parallel lines, and if lines are parallel cut by a transversal, alternate interior angles are congruent. So now I need the other side that causes this angle to be included. I already have AD. I already know that BC is congruent to AD. That's there and there. So then the other side we need to finish this off would be this third side right here. So this was given. And so then lastly, I can say that side BD is congruent to itself by the reflexive property. Oops. So we've got 2 sides and the included angle. So then that means that the triangles are congruent. Triangle ABD is congruent to triangle CDB by the side angle side congruence postulate. And that would be it. We've included the two sides and the included angle.